In this video, we're going to start PLC programming. The language we're going to use is ladder logic, and we're going to start with logic gates. So I'm assuming that you already are familiar with what logic gates are and the truth table for them. In this video, we're going to program NOT, AND, OR, NAND, and NOR. And then for XOR and XNOR, we're going to do it in next video because those two are slightly more complicated, so it will take a little bit more. Before we start programming, there are some concepts that will help you understand what we are doing better. First thing in ladder logic is that we have two vertical lines. Imagine if you're having a circuit. This is going to be the start of your circuit and this is going to be the end of your circuit. So that means that this is hot and this is neutral. And then we have some horizontal lines here. Each one of these horizontal lines are called rung. All of your inputs and output, all of your logic, it's going to be on these horizontal lines. For now, we're going to focus on two inputs. One of them is normally open or no contact, and the other one is normally closed. So normally open, normally closed. We can say NO and C. If you think of these as switches, this means in the default state, your circuit is disconnected. And this means in default state, your circuit is connected. So this is very important. When we're programming the logic gates, you will see that this really matters. Like, it's important. So these two are considered input. The sign that we are showing output is like this. So this is output. And it can be anything. It can be a coil or it can be a light. For this, we're going to assume that this is a light or LED. So whenever our output is 1, our LED lights up. And whenever our output is 0, the LED doesn't light up. I'm just gonna say this, but you probably know this. So whenever you want your LED to light up, your circuit has to be completely connected. So that means there should be no disconnect from this vertical line to this vertical line. You either have to have a closed contact or your open contact have to be energized. That means the value has to be 1. So the value for this has to be 0 in order for your circuit to be connected, and the value for no contact have to be 1 in order for you to have closed circuit. The way you display your inputs and outputs here is just simply you're going to have your inputs here, and then toward the end you have your output. You can have multiple of them, or you can have multiple of these, or you can even have it connected in parallel. So there are multiple ways that you can draw it. So these are the basic concepts of ladder diagram, and it is enough for us to start programming the logic gates. First logic gates that we are going to talk about is the simple NOT. For NOT, you need one input. We're going to consider that as A. And then this is going to be our output. NOT means whatever the input is, the output should be opposite. So if my input is 0, my output should be 1. If my input is 1, my output should be 0. So this is the truth table for NOT. In ladder logic, the way that we draw that in ladder logic, it's going to be simply just one normally closed input, and then you have an output here. So now let's look at this. This by default is closed. So if we energize our ladder logic, that means that current can flow from here and turn on the LED without any problem. That means that if you're considering this as a button, we didn't press it. So it was 0. 0 is equal to 1. So 0 and LED is on. And then if you're pressing the button, it's going to be no contact. So when we are pressing the button, that means that our input is 1, then this is going to be disconnected. So the power and the ground are not connected together. The LED is not going to light up. Next truth table that we are going to look at is for AND gate. So for AND gate, we have to have two inputs. We're going to say input A It's going to be input A, input B, and then we have an output. You want to buy apple and orange. Only if you buy both apple and orange, you have accomplished your goal. If you don't find both of them, you haven't accomplished your goal. So the first scenario is going to be 0, 0, and you will end up with 0 because you haven't accomplished your goal. You didn't find apple, you didn't find orange, so your goal is not accomplished. Next one is that you didn't find any apple, but you found orange. Then again, because you want both of them, again, you didn't accomplish your goal, so your output is going to be 0. And this is AND. That is not, this is AND. And then for the next one, you find apple but didn't find orange. So again, you didn't accomplish your goal because you wanted both of them together. And then the next one, if you find both apple and orange, now you have accomplished your goal. This is truth table for AND. This is what AND means. And then, now let's draw the ladder logic for it. So we have our two vertical lines. What we want to have two inputs. And remember what I said. So there has to be no disconnect until the output in order for LED to light up. We put A and B one after another. This way, we have one line that is dependent on both A and B. So if this is A and this is B, let's say this is A. If you want your LED to light up, you have to press both A and B. If you just press A, this is going to be connected, but then it reaches to B and it is disconnected, so LED won't light up. And then if you press the B button, then A is not going to be connected, so it won't even reach B, so the LED won't light up. Now, next one that we are going to talk about is OR. So you want to buy orange and apple, but this time is different. If you find either orange or apple, you're still successful in what you wanted to do. Now let's draw the truth table. Again, we have input A, and we have input B, and then we have output. So we said if you don't find apple and if you don't find orange, then you were unsuccessful. If you don't find apple but find orange, you're successful, because we either want one of these, or if you find both of them, it's great. So now if you find apple and you don't find any orange, you're still successful. And if you find both of them, you're going to be successful. So this is going to be OR gate. Okay, now we cannot put both of them on one line, because when you're having it on one line, both of them have to be connected, both of them have to be one in order for your LED to light up. So we cannot do it this way. We have to make it in a way that there is at least one connection. So when A or B is connected, there has to be at least one line that goes from power to the ground. Okay, so the way that we can do this is we can have two lines connected. So one of the line is going to have A on it, input A, and the other one it's going to have input B. So this is B, and then we're going to have both of these going to output or to our LED. If A is connected and B is not connected, it doesn't matter. It's gonna go from here, and it's going to light LED up. So that means that this line is going to be connected. So that means that this line is connected. And then if A is not connected, but B is connected, there is still a way to reach to the end of the circuit, to reach the end of the line. And that is going from B, and then from B is going up, and the LED is going to light up. So that means no current flowing from A, the current only flow from B, and it's going to light up the LED. So that means there is still a way for it to reach the end of the circuit. And then if both of them are connected, again, it's great, because the current can flow from both of them and light up the LED. When we're talking about the logic gate called NAND, what is NAND? NAND is basically not AND. So when you're doing not that means everything is going to be reversed. That means, so I'm going to make this pink. That means wherever I write pink, that is going to be my NAND gate. I have 0 and 0, and my AND gate is 0. But it has to be reversed because I'm doing not AND or NAND. So that means this one have to be 1. And then I have 0, 1, I got the result 0, this one have to be 1, this one have to be 1, and this one have to be 0. So I reversed it. Now I'm going to draw so now I have 2 lines, so at least one of them is going to let the at least one of them is going to be close to let the LED light up. Okay, but now we want, whenever it is not pressed, we want it to light up the LED. So NAND looks like OR because we want to get 1 when we only have one of them on. It is like OR, but then you have normally closed input. Now let's look at NOR. Again, for NOR, I can just not the OR. That means wherever I have 0 and 0, I have to get a 1. Wherever I have 0, 1, I have to get a 0. Wherever I have 1, 0, I have to get a 0. And 1, 1, I have to get a 0. So now, as you can see, whenever I have 0, 1, I want my output to be 0. So that means if one of them is pressed, I still want to get 0. If the only condition is that both of them are not pressed. So as you can see, this is very much like an AND gate. That means both of them have to be on the same line. So in order for one of them that is disconnected, the whole circuit shouldn't work. For that reason, both of them have to be on one line together, so at least one of them can cut off the circuit. So for that, we just simply use 2 input A and B, and then there is output. But then we said we want, whenever we have 0 and 0, we want to get a 1. So this one have to be normally closed. So whenever we're not pushing the button, LED is going to light up. And then if any of them is pressed, so that means we have a 1 here, we're going to get 0. If both of them are pressed, it's going to be disconnected so the LED doesn't light up.